This video is to talk about the geometrical circle laws. Before we start talking about the circle laws, we need to define a few terms. The syllabus expects you to understand these. A segment is the area that you get if you slice across a circle. Now, this part is a segment and this part is a segment. So the exam may say the major or the minor segment to identify which is the large one. A chord is any line which slices across a circle. So you could, for instance, say that a diameter is a special chord which slices across the circle and goes through the middle of it. So a chord divides a circle into two segments. A radius, of course, goes from the edge of the circle to the centre, and a radius, or two radii, divide the circle into sectors. That's the name for this type of area. It's a pie slice. And again, you could talk of the minor sector, which is this area, or the major sector, which is the area left over. And an arc represents the length around a curved edge of the circle. So the circumference is the full length right the way around the outside, the arc of the circle. Another thing before we go on to any new circle laws is something that you already know, but which the examiner quite often puts into circle questions. If you have a triangle made up of two radii, then each of those radii must be the same length. So this must be an isosceles triangle. And if this is an isosceles triangle, then the two angles at the bases of those equal sides must also be the same as each other. So if you have a triangle like this made up of two radii, then those two angles will be the same. Now we move on to the first rule. The examiner does expect you to know the proper names for some of these rules, and this is one of them. The proper name is angles in the same segment are always equal. So we've defined here what a segment is. So if you imagine the chord that slices off this segment, and you were to start two lines from the ends of that chord, any angle on the circle which comes from the same 2 points on the circumference of the circle will be equal. So all of these three angles, if you imagine me dragging this point around the circle, the angle wouldn't change. Now, for this rule to be true, they have to be in the same segment as each other, so this doesn't mean that this angle would be equal to something down here. We'll come on to that rule later on. The next rule is that any angle on the edge of the circle which comes from the ends of a diameter will be 90 degrees. So it doesn't matter where it is, doesn't matter which side of the circle it is, angles which come from the ends of a diameter will be 90 degrees. The third and fourth rules are that any angles which start from the same 2 points on the circle, well, if one of them goes to the edge of the circle and one of them goes to the centre of the circle, this one will be double that one. So if this was 100 degrees, that would be 50 degrees, for example, so long as they start from the same 2 points. And sometimes we call this the Star Trek rule. Nerds amongst you might understand why. And then finally, for this section, we've got what's called a cyclic quadrilateral, which is any four-sided shape where all the corners of that shape are on the circle. And the rule here is that opposite angles within that shape will always add up to 180. So these two will add to 180 and these two will add to 180. Now those are the basic circle laws. And then further through the syllabus, you get to these laws about intersecting chords. So we've spoken about what a chord is. A chord is any line which slices across a circle. And the rule here is that this bit of the length times this bit of the length will give the same answer as this bit of the length times this bit of the length. So you times the two parts of the same chord by each other. And this rule works if you have the chords meeting outside of the circle as well. So if you can imagine taking that point M and me dragging it out of the circle, what would happen is eventually it would look like that. And in this case, the rule is that the line from where it meets the circle to where they cross times from where it meets the circle to where they cross will always give me the same answer as the same calculation on the other side. Now if you think about it, that's the same rule as up here. We're going from where it meets the circle to where they cross times from where it meets the circle to where they cross equals the same for the other straight line. So for each straight line we're doing where it meets the circle to where the lines intersect times where it meets the circle to where the lines intersect. And then finally we move on to tangent laws. There are two relatively straightforward ones to start with, which is that any two tangents where a tangent is a line which just clips the circle, any two tangents which start from the same point out here will be the same length. So that length from there to where it meets the circle is the same as this length from there to where it meets the circle. And another simple tangent law is that a tangent always meets the circle at 90 degrees, or it always meets the radius, at 90 degrees. And then we get on to the final and most complicated circle law, which is called the alternate segment theorem, which is that if a tangent meets a triangle within a circle like this, then this angle will be the same as that one, and this angle will be the same as that one. Now it's easy to remember this if you think that this is the angle that touches this side within the triangle. So it's the same as the angle between the other two sides of the triangle. And the same for this pink one here. This is the angle that touches this side of the triangle, so it's going to be the same as the angle between the other two sides of the triangle. Now you should be able to do the worksheet.